So when you're deriving the inverse of trigonometric functions, there's a very simple trick you can use that involves understanding what the sine inverse or cosine inverse or tangent inverse and so on represent. So first of all, remember that the sine inverse of x is some angle that has sine equals x. Therefore, the sine of that angle equals x. So if I make a drawing, then all I need is that the opposite over the hypotenuse equals x. So I can very well make the opposite x and the hypotenuse 1. So if I use the Pythagorean theorem here, the adjacent squared plus x squared equals 1 squared, which is 1. So the adjacent is just 1 minus x squared, the square root of that. That's only well defined when x is less than 1 or more than negative 1, because if x were 2, for example, that would be a big problem. That would make this a 1 minus a 4, which is minus 3. I can't take the square root of minus 3, so I have to be careful with that. But with that in mind, I can start my derivative from scratch. Look at the second line there. Sine theta equals x. I can derive both sides with respect to x, d dx of sine theta, d dx of x. The right hand side is okay, it's easy. That's just 1. But the left hand side does not have variable x, it has variable theta. So what I need to use is the chain rule. So I derive d theta of sine theta times d theta dx. So it's dy d theta dx. Those two cancel. If I wanted to go back to where I started, which shows me that my use of the chain rule is correct. And now I have a simpler calculation. D sine theta d theta is just the derivative of sine theta with respect to theta, as if theta was playing the role of x. The derivative of sine is just cosine times d theta dx, which is exactly what I want to know because theta is sine inverse. So this is the derivative of sine inverse, right? Because that's theta. So this is what I want to know. I'll pretend like this is my unknown, which it is. Now keep this on the left side and move cosine dividing over to the right side. So that's 1 over the cosine of theta. And from the calculation on the left, just look at the triangle and you'll see the cosine is the adjacent over the hypotenuse. This is the adjacent. This is the hypotenuse. Dividing by 1 doesn't change anything, so this is the cosine, root 1 minus x squared. This is root 1 minus x squared. Again, the only thing you have to be careful about is that x is between negative 1 and 1, because if it isn't, then the thing inside the root becomes negative. You can repeat this argument with cosine inverse, tangent inverse, cosecant inverse, and all the other trig functions and their inverses, and you get a table such as this one if you do.